Assalamualaikum. My name is Karul CD, and in this video, my group will present the performance of McDonnell Douglas F-18 Hornet, or simply known as F-18. So first, in order to do the necessary calculation to find the performance, we have searched for all the data in the internet that are necessary to do the project. So the table I'm showing here is the compilation of the data that we have found so far regarding this chat. So first, let's move on to the first part, which is the thrust required. So, assuming the cruising altitude of an F-18 jet is 35,000 feet, and the takeoff weight based on the data, the takeoff weight is 36,970. The aircraft wing area is 410 feet square, and the aspect ratio is 4. So CD naught is 0.05, and CD can be calculated using the formula CD equal to CD naught plus KCL squared. But first we have to calculate the K value. So by using the spin efficiency that is assumed to be 0.9, we can calculate the K, which is 0.09. So next we can calculate the thrust required using the these three formula, which is first the formula of CL, and uh, by using the value of CL, we can calculate the CD using the formula of CD, and by using the value of CD, we can calculate the thrust required. So to make things easier, I have done the calculation in Excel spreadsheet using all those formula, and these are the result form for 10 different freezing velocity. So the figure below show the thrust required versus speed of aircraft. So next, I will present the calculation for maximum CL over CD and CL to the power of 1 over 2 over CD. So for maximum CL over CD, we can use the formula here, and by using the data that we have found, and we get the CL over CD is 13.0.83, and for maximum CL to the power of 1 over 2 over CD, we can calculate using the formula, and the value of maximum CL to the power of 1 over 2 over CD is 24.2746.
For the rate of climb, rate of climb is essential for aircraft to overcome the obstacle from getting out from the turbulence by climbing to higher altitude. So figure 1 show the force and velocity diagram for climbing flight. And in general, the calculation for rate of climb is equal to R over C equal to V sine theta. Table 2 show the data that we need to calculate the climb performance. And we already have rate of climb, Mach number, and speed of sound. So as we already have rate of climb, we only need to find the climb angle. To find climb angle, first we need to find the value of velocity of the airplane, which is V. After we get V, we can use the value of rate of climb to find the climb angle, and we will get climb angle 53.74. From this, we know that the jet F-18 need to climb 33.74 degree to avoid the obstacle so that it can climb to higher altitude. So that's all for rate of climb.
So next, I will present on the range and endurance. So range is the total travel by the aircraft that is measured with respect to the ground on one load of fuel. So by using the formula and all the data that we have found, and the R can be calculated, and the value of R value of range is 725,499.83 feet. Well, to calculate the endurance, we have to use this formula and all the data that are needed, and after we calculate, we get the endurance value into is 3.711188 hour.
Now, let's move on to the accelerated flight performance. I'll be presenting level turn and also pull up and pull down maneuver. So now first let's look at the level turn. The level turn is one in which the curved flight path is in a horizontal plane parallel to the plane of the ground. The altitude remains constant. The centrifugal force is balanced by the radial force. And this is the picture of the aircraft. And also now let's look at the minimum turn radius and also maximum turn rate. So in order to gain all these values, we need to assume the rho S, which is the area, the thrust, and also G. And also there is a coefficient CDO and also AR and E to find the K. And the formula that are being used are shown in the slide. And now let's go to the calculation. So in order to find the minimum radius and maximum turn rate, we have to calculate the value of K first, which is 1 over pi aspect ratio and the times to the efficiency factor. And we will get 0.0837. And using that, we can find all the minimum radius by using the equation shown and also using the unknown values which were assumed. And then next, let's go to the pull up and pull down maneuver. So a pull down maneuver is occurs when the plane banks to a steeper angle of attack, causing lift to rapidly increase. In the vertical plane, the flight path becomes curved with a turn radius and a turn rate. So in order to find the turn radius and turn rate during pull up, we will use the equation shown, and we will I assume that the G is 32.2 and V is 820 mile per hour, and also the load factor is 7.5. And by using that, we can find the turn radius, which is shown here, the turn radius and also the turn rate. And next, let's go to the pull down maneuver. When the plane is rolling upside down with L and W, which is lift and weight pointing down, the pull down maneuver occurs. So same as the pull up maneuver, the same most similarly the equations are same. So now we can just use the equation to solve the turn radius and turn rate. Thank you.
For the takeoff performance analysis of jet F-18, we need to find the value of takeoff ground roll and takeoff distance whatever. Based on the figure 2, this is the illustration of ground roll and airborne distance and the total takeoff distance. So this is the data of takeoff performance that we need to use to calculate the SG and SA. First is takeoff gross weight, wing area, engine thrust, and wing sweep angle. And there are three constant value that will be used to find the SG and SA, which is density at standard sea level, gravity, and height obstacle. So for the first step, we need to find the value of CLmax. CLmax can get from the ratio of CLmax over cos angle, and we can get this value from the table. And then we need to find the lift of velocity, which is VLO. And first we need to calculate VSTOL and then substitute it into this formula, and we will get the value of VLO. After that, we can find the value of takeoff ground control, which is SG. And then to calculate SA, takeoff by airborne, first we need to calculate, find the value of R and theta OB. After that, we can find the value of SA. And then the total takeoff distance can be get by sum up the value of SG and SA. And we will get the takeoff distance, which is 5644.51 feet. That's for the takeoff performance.
Well, my name is Ganesh Rao and my metric number is 206116. Now I'm going to talk about the landing performance for this aircraft, which is F-18 Hornet. For this aircraft, we assume that the runway threshold height is 50 feet. So this is the illustration for the landing. This is the value that I have searched for these calculations, which is approach angle, reverse thrust, coefficient lift, coefficient drag, and KUC. For coefficient lift or maximum coefficient lift is 0.95. From there, we could calculate V stall, which is stalling velocity. Then we could get 343.3569 feet. For the average flight velocity, which is VF, is 23% of stalling velocity. So we could get 422.3 to 90 feet seconds. The touchdown velocity is as similar as the flight velocity, but the percentage is 15%. So we multiply with 1.15 we stop. So then we can get 394.804 feet per second. Then we calculate R value and HF value. Using the R value, we could get HF value. For the R value, we calculate, then we can get 2,769.529 feet. For HF value, using the angle, we get 6.7466 feet. The approach distance is usually we calculate using the trigonometry method. Then we can get 618.5524 feet. Flight distance is 193.1970 feet. For JT value, to calculate the ground roll distance, we can get the JT is equal to 0.4. Before that, before we calculate SG, we could get drag coefficient and G value to calculate JA. For drag coefficient is 0.0011 and G is 0.9735. Then therefore we can get JA value, which is negative 2.0920 times 10 to the power of negative 7. Since this is landing performance, so the value is in negative. For the ground roll, we assume that n is equal to 3. Then we calculate it, and the value is 1199.911 feet. Finally, we sum up the ground roll, flight distance, and approach distance. By that, we can get 2011.6606 feet. So this is the final total landing distance for F-18 Hornet. Thank you. That's all from me.